Tigers. We are talking about page 31 of your notes today. We are going over real numbers. All right, guys, so today our essential question is how can you describe relationships between sets of real numbers? Okay. First thing we're going to do is we're going to talk about our only vocab term today. So that is real numbers. Real numbers can be rational numbers or irrational numbers, okay? And we talked about those in our previous lesson, so you guys can refer back to that video or page 30 of your notes. Okay, so now that we know what a real number is, okay, it's just an irrational number or a rational number. So I've got this chart over here, okay? It kind of helps you guys organize what different types of numbers are. So all numbers are real numbers, okay, until we get to imaginary, but we're not talking about that today, so don't worry about it. So for our purposes, all numbers are real numbers today. After you know that, they can be either rational numbers or irrational numbers, okay? If you guys have an irrational number, that's the classification. There's nothing within irrational numbers. There's no other categories here. All right, and then within rational numbers, we also can have integers, okay? Those can be positive or negative, okay? And then we have whole numbers. Those are all positive or zero, okay? So integers are basically whole numbers that can be negative, okay? A whole number is just going to be positive. Okay, and you guys will notice we have a square root here. Whenever you guys are identifying a number and like what category it can go into, you guys have to simplify. So if I took the square root of 4, I would get 2. Okay, so that would be a whole number. Okay, all right, so we're gonna go over how to classify. All right, when you guys are classifying, you have to list all the names that apply to that number. Okay, sometimes it can get a little time consuming and it can get a little space consuming also. Okay. Looks like it. We back? Okay, we're back. All right, so here's some examples. We've got square root of 36. Okay, if we were to simplify that, we would get 6. Okay, guys, for the purposes of classifying numbers, when we've got a square root, we're just going to do the principal square root, which if you guys go back to a previous lesson, that's the positive square root. Okay, that's why the square root of 4 is a whole number, because we're not taking into account the -2 that it could also be. We're just going to use the principal square root. So this one becomes positive 6. Okay, so positive 6 is, so they're all real. So it's real. It's also rational. It's an integer. And it's also a whole number. Okay, guys, so if you guys end up with a whole number, you get to label all of these. Okay, this one, if we were to simplify, -18 divided by 6, that would give us -3. Okay, so again, it's real, it's rational, and it's an integer. It, however, is not a whole number because it's -3. So we just say real, rational, and integer. Okay, 0, it's one of our examples. So again, that one's going to be real, rational, an integer, and a whole number. Okay, square root of -28. Okay, I don't get an actual number when I take the square root of 28. Since I can't get a whole number when I take the square root of this, that makes this irrational. Okay, guys, so we talked about that before. If I were to take my calculator and do second function square root of 28, I get this decimal that just keeps going. It doesn't terminate, so it doesn't end, but it also doesn't repeat. So this is an example of an irrational number. So this would be real, and it would be irrational. Okay? So that's classifying, guys. First thing you gotta do is simplify if you can, and then you have to write all the names that apply to that number. Okay? Easiest thing to do is start with real numbers. Okay? Because look at real, 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 real. These are all real. We're not talking about imaginary ones yet. So basically everything that we're going to talk about today it's all going to be real. Then you decide, is it rational or irrational? If it's irrational, you're done. If it's rational, then you go, okay, is it an integer? And if it's an integer, then you check if it's a whole number. So guys, I want you guys to answer this. We'll talk about this in class. True or false? Some irrational numbers are integers. Explain your answer. So guys, I am not just looking for the true or false. I am looking for the explain your answer. Okay, that's what we're going to talk about in class is the explaining your answer. So please make sure you guys do that before class time. All right, so next thing we're going to talk about is identifying sets for real world situations. So it's all well and good to be able to identify the number. What we want to look at now is what type of number will you use for a given situation. Okay, I want you guys to check out this kind of oval up here. When identifying sets of a number, you only need to identify the biggest classification for the number, not all the classifications. So this is a little bit different. When we were classifying the actual numbers, we listed all of the different types, like all the categories that it can fit in. But when we're doing real world situations, we're just going to name the biggest one that describes it without describing things that it's not. Okay, so biggest, you guys have to be careful with that because it's not biggest in like whatever category it is, choose the biggest thing. And I'll give you an example of that, guys. Otherwise, we would just say real numbers for everything, which is not what we're going to do. Okay, so here's our first example. The number of people wearing glasses in a room. Okay. Number of people, we can only have a whole number of people. There can't be half a person wearing glasses. Okay? You're either wearing glasses or you're not wearing glasses. It's a whole number. Okay? And it can't be an integer. So if we look back up here, integers are whole numbers that have negatives. Negative people can't be wearing glasses. We can't have a negative number of people wearing glasses. So the biggest thing that we can do without including things that don't fit our situation is whole numbers. Okay. For example 2, the number of seconds remaining when a song is playing, displayed as a negative number. This one, guys, is a little bit bigger. This is actually going to be a rational number. Okay, it's a rational number because it could be it can't be a whole number, but it could be an integer. Okay, because it says that it's displayed as a negative number. So we know it can't be a whole number, but it could be an integer. It could be -5 seconds, -7 seconds, -12 seconds, things like that. But we're going to say rational number because it could also be a decimal. We could have -2.7 seconds left. A lot of countdown clocks actually go to tenths or hundredths places. So that's why it's going to be rational, because it doesn't say that it has to be a whole number or an integer. Like it doesn't have to be -10, -2, -17. It doesn't have to be an integer. It could be a decimal. That's why that one's going to be rational numbers, not integers. Okay? And then the last one that we're going to do is example 3, markings on a standard ruler. Okay, I'm actually going to have you guys do this one on your own, and we're going to talk about it in class. So make sure you guys do example 3 on your own, and we'll answer it in class. All right, so what I want you guys to do, if you have any questions about this lesson, please put them in the very large your question column. And then I want you guys to take a look at this bottom question here. How can a number with a radical symbol, so square or cube roots, be classified as a whole number? So how can you get a whole number classification when you have a radical symbol? All right, go ahead and answer that, and we will talk about that in class also. And I will see you guys in class.